Hi, I'm Zimmerman. I am the head of product engineering here at Zimmerman Manufacturing. My start with the company was 4 years ago. I started on running the lathe and just kind of progressed from there. Filled a need that we seen and started in the CAD drawing. And since then, I've been full-time into the engineering side where come up with products like this. So I'm standing in front of our TR 1924. It is a 40-foot wide Manure injector with a dragline 8-inch swing pipe. All right, so our Red Viper injector, we have Hydroflex on it where these units go up and down individually, like they're tied in a closed system. So each one can walk as the contour in the field can go. They have 10 inches of up travel and 10 inches of down travel. Side to side flex, I think it's 25 degrees, allows you to do in-ground turns. So when you get to the end of the field, you can leave it in the ground to turn around and do your J turn and go back, start again. This one here is sold to a custom applicator. They go around farm to farm and they're pumping, I think, 3,500 gallons per minute with this one. So they're upgrading and they really like what they've seen from our field trials. We have no negative tongue weight on this one. We built our axles behind our front bar here. So all our weight of the front and the swing pipe is on the tractor, or it's fairly evenly distributed. Then the second thing would be flotation in wet fields. Some guys, when they get out into a muddy field, they try to lift up, the tires just go down and sink. Here you can lift a little bit of the weight up and get through that muddy spot without getting your tractor stuck. So on this model here, we offer our split system where we have 2 flow meters on it. Right here, the Manure comes in and it goes to a T and we funnel back through. We have a flow meter and then a control valve. The control valves are run separately on gallons per minute, so each side should be getting even flow. Like the one side is open 100%, the other side opens and closes as needed to keep the flow even. It goes into our manifold on the wing. The reason we went to the manifold on the wing was to keep our hoses a little bit shorter to allow more even flow. On a hillside is where this will really stand out. When you're on a hill, the flow should remain even as the valves open and close on it. The other benefit that we have is we mount our swing pipe in front of the tires, which allows for a sharper turn without any sideways pull on it. The hose actually gains some slack when you're doing your turn. So this is the third one that we built now. And from the first one to the second one to the third one, we've changed every time. We've changed something on it. And this one, we're pretty happy with how it's turned out. Double toolbar, like to gain a little bit more strength and stability for the wings, which also helps with the tower, gives a little more support for the swing pipe tower. On the first two, we had our manifolds on the center where we had long hoses running out to the row units. This one, we had a customer that requested that or the second one, he went and moved his manifolds out onto the wing and he said he liked that better. So we took that design and kind of put it onto ours for this one. So this right here would be our depth control gauge. That shows you where your row unit is for like when you're running, whether it's level or whether it's tipped down or whether it's tipped up. This will show you exactly where that unit is running. That way, if you get a new operator in, you can tell him to set the control gauge at say 2 or -2, and everyone will know exactly where it needs to be.